Module 2, Losses of Prestress. After the end of this video, students will be able to estimate the losses of pre-stress in pre-tension and post-tension PSC beam. In the initial module 1, we have analyzed the PSC beam for stresses. Now in this module, we will be estimating the losses of pre-stress. The initial pre-stress introduced to counteract the stresses coming from the external loads whose analysis was done in module 1. Now this initial pre-stress undergoes a gradual reduction with time from the stage of transfer due to various causes. This is generally referred to as loss of pre-stress. It is very much essential to estimate these losses in the design so that effective pre-stress to be applied can be determined so that stresses from external loads can be counteracted to a desired degree, either 100% or partial. Hence, effective pre-stress is equals to the initial pre-stress plus the losses of pre-stress. Now coming to the types of losses. Losses in pre-stress can be classified based on time which they occur. The losses that occurs during the process of pre-stress is known as immediate loss. And the loss that occurs after the pre-stress is transferred to concrete, that loss is termed as time dependent loss. Now let us see the various types of losses, and we will just list those in terms of pre-tension and post-tension. Loss of pre-stress occurs due to elastic deformation of concrete in case of pre-tension. Similarly, in post-tension, if the wires are tensioned successively, one after the another, then there will be loss due to elastic deformation in the earlier tensioned wire. But if the wires are simultaneously tensioned at a time, then there will be no loss due to elastic deformation of concrete in case of post-tension. Nextly, loss of pre-stress occurs due to relaxation of stress in steel. Similarly, the relaxation loss is also there in case of post-tensioned beams. Nextly, there is also loss due to shrinkage of concrete in case of pretension as well as in case of post tension beam. Nextly, there is also a loss due to creep of concrete in case of pretension as well as in case of post tension. Nextly, in addition to these four losses in post tension, there are additional losses which occurs due to which do not occur in pre-tension but occur only in post-tension. Those are friction loss between friction between concrete and tendon and concrete and the duct, as well as loss due to anchorage slip. These two losses are the additional loss in addition to 4, but these two losses will not take place in case of pre-tension beam. In addition to all these losses, there may be losses due to sudden changes in the temperature, both in case of pre-tension and post-tension. This rise in temperature causes partial transfer of pre-stress, partial transfer of pre-stress, which may cause large amount of creep if concrete is not properly cured. So these are the various losses. Now coming to in detail how to estimate these losses, we'll see those. Firstly, loss due to elastic deformation of concrete. The compressive pre-stress in concrete causes elastic shortening in concrete and thereby reducing initial tensile strain in steel. This occurs immediately after transfer of pre-stressing force from the external support. Suppose if Fc is the pre-stress in concrete at level of steel, Es is modulus of elasticity of steel and Ec is modulus of elasticity of concrete. Then the modular ratio which is defined as a ratio of Young's modulus of steel to Young's modulus of concrete. Now the strain in concrete at level of steel is equals to the stress divided by the Young's modulus, that is Fc divided by the Young's modulus of concrete Ec. This is the strain in concrete due to elastic deformation. Now corresponding to this stress in steel is corresponding to this strain, the stress in steel is Es divided by Ec, strain into the Young's modulus. The strain is Fc by Ec is the strain multiplied by the Young's modulus of steel. Hence, the equation is Es by Ec into Fc. This Es by Ec is nothing but the modular ratio alpha and then multiply by Fc. Hence, loss of pre-stress due to elastic deformation is equal to alpha times Fc. This is the required equation for the loss of pre-stress due to elastic deformation. Now suppose in case this is for pre-tension as well as post-tension, but if, due to successive tensioning, if the successive tensioning is done, then the loss will be alpha times Fc. In case of post-tension I am talking, this then the loss will be alpha times Fc if first cable is tensioned. This is alpha times Fc in the first cable if this while tensioning the second cable. Similarly, if the third cable is being tensioned, then the loss will be alpha times Fc in first cable as well as the second cable. Similarly, if the fourth cable is tensioned, there will be loss of alpha times Fc in first, second and third cable. So similarly, we need to estimate the losses if there is successive tensioning is done. And while tensioning the first cable, then there will be no loss. Only when tensioning the second cable, there will be loss in the first cable. This is in case of post tension, if successive tensioning is done. If successive tensioning is not done, simultaneously tensioning is done, then there will be no loss. Now coming to secondly, loss due to shrinkage of concrete. The loss of water for short duration of a time, which increases the shrinkage strain and hence loss of pre-stress occurs. These shrinkage as well as creep, these are the short shrinkage is the short duration time loss of water. Suppose if epsilon Cs is the total shrinkage strain total shrinkage strain. This is total shrinkage strain as per IS 1343 is given by epsilon Cs is equal to 300 into 10 to the power of minus 6 for pre-tension and 200 into 10 to the power of minus 6 divided by log to the base 10 of T plus 2 for post tension, where T is the age of concrete at transfer in days. Hence, loss of pre-stress due to shrinkage of concrete is equal to the strain multiplied by the Young's modulus. Hence, loss is equal to epsilon Cs the total shrinkage strain and the Young's modulus of steel. This is the loss due to shrinkage of concrete. Now coming to the loss due to creep of concrete. The loss due to creep of concrete is caused due to sustained stress as compared to the shrinkage. There are two methods to estimate the loss due to creep of concrete. The first method, which is called as the ultimate creep strain method. If epsilon cc is the ultimate strain, and Fc is the compressive stress in concrete at level of steel, then loss of prestress is loss of prestress due to creep of concrete is equals to the strain epsilon cc into Fc multiplied by the Young's modulus of steel. This is the loss of pre-stress due to creep of concrete. There is another method which is known as the creep coefficient method, method 2. Creep coefficient method. If phi is the creep coefficient, which is defined as creep strain by elastic strain, that is epsilon c divided by epsilon e. Now the loss of pre-stress is equal to the creep strain multiplied by the Young's modulus of steel. So this creep strain is epsilon c, which is phi epsilon e as per this equation, multiplied by the Young's modulus of steel. This epsilon e is Fc stress by the Young's modulus of concrete. That is, elastic strain is the stress Fc divided by Young's modulus of concrete multiplied by the Young's modulus of steel. Now rearranging the terms, we get loss of pre-stress due to creep is phi, this Es by Ec, Es by Ec is nothing but alpha, phi alpha, this Fc, phi alpha Fc, where alpha is the modular ratio. Hence loss of pre-stress due to creep equation is phi alpha Fc. We also know that this alpha Fc is the loss due to elastic deformation. Hence, this is also phi times the loss due to elastic deformation of concrete. Now coming to loss due to relaxation of stress in steel. Relaxation of stress in steel. When HTS wire is stressed, HTS wire is stressed and maintained to a constant strain. Suppose if we are trying to stress a steel and maintain to a constant strain, the initial force or the stress P in the wire does not remain constant, but what it actually is, it decreases with time. This decrease of stress in steel at constant strain is termed as relaxation of steel. As per IS 1343 1980, it recommends to determine this loss. From laboratory tests. In absence of the laboratory test, the loss due to relaxation at 27 degree centigrade for 1000 hours may be taken as per the table. Initial stress, depending upon the initial stress, the loss can be as per this table. If the initial stress is 0.5 times FPU, the loss is 0. If the initial stress is 0.6 times FPU, the loss is directly 35 Newton per mm square. If the initial stress is 0.7 times FPU, the loss is 70 Newton per mm square. If the initial stress is 0.8 FPU, the loss is 90 Newton per mm square, where FPU is the characteristic strength of pre-stressing tendon. So with this, we have estimated the loss due to shrinkage or elastic deformation of a concrete, shrinkage of concrete, creep of concrete, and relaxation of stress in steel. So in the next video, we'll see the additional losses in post tension beam, which is due to frictional loss and anchorage slip.